We had this idea that visualization would be hard to monetize, particularly for this like physical AI kind of applications. You need to visualize every single step of everywhere you might interact with data. So we've actually redesigned the data model probably 4 times at this point.
Oh, wow. AI and robotics, it seems like such a hot topic. What are you seeing that people might not realize that's working now that didn't work a year ago?
So we're just really seeing an incredible progress in sort of ability to do quite advanced manipulation. This has been a really difficult problem in robotics for a long time. Another one is reinforcement learning. And classically, that's been for walking and motion. And what's starting to work a lot now is kind of combining some of that reinforcement learning with imitation learning.
Are there benchmarks that should be created?
There aren't any great benchmarks. The way often to solve real problems is to co-train and co-design for your hardware. It's like you design these things together, and then it becomes quite hard to benchmark in a good way.
You're listening to Gradient Descent, a show about making machine learning work in the real world, and I'm your host, Lukas Biewald. All right, this is a conversation with Nikolaus West, who is the founder of Rerun.ai, which is a company that I've admired for a while. They're in a similar domain to Weights and Biases, robotics and embodied AI and augmented reality. And they have a very cool logging product that operates at super high scale, and then a database or a kind of system of record for bigger customers to track everything they do. They've made a lot of interesting decisions, some same, some different than Weights and Biases. So it's fun to get into the weeds about how their product works and how they think about it. It's also just interesting to talk about robotics and the state of the art because it might be the coolest application of AI right now. Hope you enjoy it. All right, so maybe I'll start with a little bit of why I wanted to talk to you on this podcast. So, so you're the founder of Rerun, which is a company that does logging for robotics and also kind of functions as a system of record, it seems like, for robotics companies. And it's very similar in some ways to what we do at Weights and Biases for, AI teams.
Yeah.
And, looking at your website, it seemed like you emphasized a lot of the same things as us, like a simple API, like high speed logging. And it also seems like you have a similar customer love to Weights and Biases that I really respect and admire. And maybe not a lot of people know this, but the original use cases of Weights and Biases were pretty heavily in robotics. Actually, OpenAI, when we first started working with them, their main focus was robotics. This was before GPT. And you can actually find an interview with Wojciech, very early interview with Wojciech, one of the founders of OpenAI, talking about robotics projects there. It must have been like 5 years ago. So anyway, you started your company a few years ahead of us in a different domain and, made a lot of different decisions. So I was really excited to talk to you about kind of your kind of creative and product process. And also, I think everybody loves robotics and the applications, and maybe we call it embodied AI now. So maybe we get into that too.
We get compared to Weights and Biases every now and then, and that was one of the early signs that we were really happy about our API when people are saying, yeah, it's like Weights and Biases for robotics or spatial computing and that kind of field. So yeah, where do we want to dig in first? Basically.
Yes, maybe we should start with what are the range of use cases that you're typically used for, and how does Rerun work there?
Got it. Yeah. So maybe just set the scene. So Rerun, we have an open source project that is very popular. And that project is an SDK for like logging, modeling, querying, and visualizing like really multimodal data, and particularly multimodal data that changes over time.
So I'm picturing like sensors from like a LiDAR or images.
Like 3D sensors, set up for multiple cameras moving around. Maybe you have regular RGB, and you have motion sensors, and you have whatever other normal signals and tensors, and if you think it could be, so our first early beachhead was in spatial computing or augmented reality, so like companies building headsets and that kind of stuff.
And so what are they logging there?
You're logging like sensor, like images. You're logging camera calibrations, where a camera is in space, as well as just normal text logs, and you're logging time series that could mean whatever, just CPU time or some confidence of a neural network or anything like that. So just both the input sensors that you have and any sort of internal computation that you might do. So the output of a neural net, or so little bounding box that you detect, or anything like that. So yeah.
And where has it gone from there?
So yeah, it started out as that, really focus on, we just wanted to make it like 100 times easier to like debug these sort of multimodal systems, like computer vision or robotic systems that do things over time. And that really was the focus quite heavily in the beginning, and got a lot of first usage in spatial computing, and then quite broadly, I mean, it's used in like hedge funds and like weird different things, but then now very heavily in like robotics, and particularly learning first robotics. And so on top of that commercial or sort of open source project, we built are currently building a data platform. It's a bit more like a cloud database or a data lake house, even if you want to kind of get into that. So for really focused on kind of making it a lot easier to get data from a robot to like in the right shape and the right subset of that into training on it, basically. So that like running that like record data, curate and train loop as fast as possible, but not taking part in the training, which is what weights and biases does, but the kind of data pipelines leading up to it.
Interesting. So, I mean, I can see how, you start in kind of VR, AR, and then, you move into robotics. But what is the hedge fund logging on your platform?
Yeah, I think we just have all this breadth of random use cases as well. I guess it ended up, we put a really lot of effort into performance and ease of use. And so it actually turns out it's like pretty difficult to get really fast, simple to install streaming visualization of even simple things like time series and so on. And so we put a huge amount of effort into, we built a in-memory database from scratch, basically, that runs inside this like visualization app. And that can speed things up and it's like highly performant and easy to use, basically. It's not perfectly meant for that, so it's not like I don't imagine that will take off in a big way, but we find a lot of those things, random use cases like that as well.
Interesting. And I noticed, just like weights and biases, it seems like your kind of core API call is a .log.
Yeah.
And I think like one of the things we often thought about was, how kind of opinionated to be about, people's data types, and like how opinionated to be about displaying them. Like, how did you like think through that trade-off?
Yeah, so that came from, I mean, first, it's a really important trade-off, and I think one that we got, I don't want to say like right, but got pretty good.
You can be proud of your product.
Yeah, I'm quite proud of it. It did go well. Of course, there are always like things that we want to improve, but I've built similar systems many times. So the three of us co-founders, we worked at a 3D like computer vision company a long time ago, and we built something similar there. And where the idea was, you want to be able to log all your data, including this like images and 3D and all those like the weird data, and had kind of built several versions of this at different companies, and came in with this idea that it was really important to have it be incredibly low friction when that's what you wanted. So if you're debugging one of these systems, there's so much state in your head, right? Very similar to bugging like machine learning training. So it just needs to be like dump and forget. Just no thinking, as like high level, very easy. But then with experience building these things in maybe more rigid ways, and you can always get stuck somehow. So it's very important for us to have it be flexible, so that you can kind of, okay, I added in this like maybe output from a neural net or a 3D point cloud or something that my neural net is estimating. But I want to understand like what was the confidence level of like this one point, and I want to just hover it and look at it. And then you need to make that work. I can't upfront know what all the users' data models are going to be. You have to have a very flexible data model. So we designed a sort of new data model from scratch, inspired by entity component systems. This is like a way of modeling data in games. So a couple of the early employees had a gaming background, and basically we designed an entity component system.
And what does it mean? How does that work?
It's basically Yeah, let's see if I can explain this like very, very simply. But instead of objects, okay, if you're a normal object-oriented program, you might have a object. You say, okay, you have an image. It has its size. It has the memory buffer with the things in it. You have sort of memory buffer is one thing. Image size is another, and you can kind of just compose all these components. And then there are systems that know how to interpret. So there's some visualization system that says, oh, if I see a image or like image buffer and of size and all these things that I need, then I'll just draw it.
Mm-hmm.
And so it's a bit more flexible than saying, okay, we just have this fixed object that we know about how to deal with. We can like easily compose sort of things that you might want to visualize or log or understand more freely, basically.
And so what are the most common things that people are logging here?
So if we go to sort of right now, where it's like really popular right now, Rerun is particularly popular in like heavy learning-based sort of AI-first robotics. And there people are logging like motion sensors, image or video. So it's like really important to have flexibility in high performance and like how you represent video, as long together with just other debugging system things that you might have in a robot. So those would be the most important things there, and then point clouds and lidar kind of sensor.
So maybe we could talk about this, the kind of state of the art of AI and robotics. It seems like such a hot topic. Like, what are you seeing that people might not realize that's working now, that's in work a year ago?
I think this last couple of weeks has been like incredibly exciting. I don't know if you've been following all the releases.
Maybe not.
Yeah.
What are they?
So we're just really seeing an incredible progress in sort of the ability to do quite advanced manipulation. So this has been a really difficult problem in robotics for a long time. It's classic robotics is just like built around being incredibly precise. You pre-program every movement up front, and just everything has to be down to the sort of millimeter precise. But this kind of flexible, messy manipulation of like folding laundry is a classic task, has been really elusive for robotics for a long time. And it's just sort of folding laundry has kind of gone from being impossible to sort of boring over the last year, basically. And it's really kind of come through these like end-to-end learning methods. First, on those like manipulation tasks, basically imitation learning. It's a kind of robotics version of supervised learning.
Can you describe how imitation learning works for folks who might not know?
Yeah. So the simplest case is you teleoperate your robot. So that means just a person is remote controlling the robot, and you record everything that happens. So let's say you want to fold clothes. You have like one episode, you record data as episodes. So that would be take a piece of clothing from the hamper or whatever and put it on the table and fold it and put it in a pile or something like that. That could be like one task. And so that so you collect data like that, just basically demonstration data, and you collect all the state of the robot at every timestamp. So what are all the joint angles and some perception or proprioception like input, basically, that you can use and in simple terms, just train some neural net to repeat that task. But obviously, this is a real messy world, so it's never going to be an exact replica of the task. But that's the kind of robustness that you try to train in. So I think it was about 2 or 3 years ago that started to kind of really work in a sort of more serious ways, and that really started this really, really heavy excitement in the sort of AI first robotics that's happening right now. And there's been that's sort of one of the learning paradigms. Another one is reinforcement learning, and classically that's been for like walking and motion and things like that. And what's starting to work a lot now is kind of combining some of that reinforcement learning with imitation learning. So we're seeing some like really, really awesome results, like very robust robotics sort of manipulation handling coming out over the last couple of months. That's yeah.
And do you think it's been like algorithmic insights that have made these strategies work, or is it, a bigger focus on training data or kind of better hardware platforms that actually, work better, or more compute, or
Yeah,
what's driving this?
I, I think it's all of the above. Um, my view tends to be that generally the things that matter more, maybe more this like ecosystem or like economic engine or something like that. I think what I maybe see as the big arc is that the sort of LLM hype, ChatGPT moment kind of thing really showed to the world the power of like really scalable machine learning.
Mhm.
And then that really primed everybody to be looking out for signs of could we have a scalable learning work for robotics? Because previously it's been this thing, yeah, you add more training data, it gets worse.
Mhm.
Is it the models don't generalize? And then a couple of years ago there was a bit of a breakthrough that just you could sort of start seeing the signs of scalable methods kind of working for robotics. So that includes using transformers, but there were a bunch of innovations that had to be made in terms of just how do you model a robotics problem, which is different than a sort of text problem. So in the mix, but then that gets going, and then more people get money pulse in, more people get excited. So there's more hardware being built, so that gets cheaper and cheaper, and then people want to. Everybody knows it's scalable, so that means you have to have a lot more training data. But there's enough excitement to invest in collecting data. So
My impression of robotics right now at this moment in late
yeah,
2025 is, I'm super excited about it,
yeah,
obviously, and
yeah.
I see these like amazing demos, all the time.
Hmm.
But then when I visit our robotics customers, the demos don't seem quite as impressive as like
Yeah,
the YouTube videos,
yeah,
that I watch. And I'm not talking about the Boston Dynamics ones where it's obviously like,
yeah,
like kind of more traditional robotics, but even the ones where, you see this really kind of fluid motion,
hmm,
clearly like trained. Um, well, I don't know. I mean, I would love to buy a robot that, folds laundry, but I don't
yeah.
have one. Like what's like the gap right now? How far is the gap, and how would you characterize like the state of the art of robotics?
I think there are different like kinds of robotics companies. So I think there's a lot of that, and the ones that are more maybe swinging for the fences directly, I want to call it
Mhm.
that. Then you see these incredible demos, and then it's actually quite far from a product. But I do see another batch of robotics companies that have a very different approach. They're much more practical. They build robots, scrappy robots early and ship to customers and like have a working product, and they're just aggressively deploying that. So those don't get as much hype because it's not as exciting to look at. They kind of not aesthetically pleasing warehouse robot that is just like
Let's talk about the
so
working
yeah,
robots that you see like in
yeah.
warehouses. Like what's happening now?
So they're really using a lot of the same models, but maybe not as heavy focus on research. So in parallel to all this that's been happening, there's also been a lot more open source models coming out. Also, the same way in LLM land, there are some great open source models, heavily driven by Hugging Face. Um, so I see them being just kind of scrappy, using these like VLA models. So that's vision language action models. But maybe just being more practical about building other systems around them and kind of using teleop where needed, and kind of just have a more product and like scrappiness sort of approach to making things work.
And to be like practical, like what are
Hmm.
you actually seeing? Like are there, I mean, I've talked to guests on the podcast, I think of sort of
Yeah.
every, realm
Uh-huh.
of this, every like spectrum. And certainly like, we talk to folks that have like, carts in factories where you can like put something on it and the cart will like go,
Yeah.
to the next location. That seems like clearly factories are doing that.
Hmm.
A lot of people talk about, like kind of picking stuff up in factories and moving it.
Yeah.
Although that one doesn't seem as, I mean, that's some people have been dreaming about that for like years and years and years. Like, is there actually like picking up objects like happening in real world factories, and is it mattering? Is the state of the art past that in terms of like what's actually deployed in production?
I would call it that there are pockets where it's working, but it hasn't been scaled up.
And what are
Yeah.
those pockets? That's I guess what I want
Okay.
to.
So pockets are more like it is actually possible to do this now.
Hmm.
So we see companies that have deployed, in the tens to 100 robots in like manufacturing, and they use these kind of flexible learning based sort of manipulation for like moving stuff in manufacturing, for instance. So just be simple stuff like pick and place.
Mhm.
And yeah, that's basically, they have that working, but it's not like at massive scale yet, basically. But there are smaller companies that are growing their amount of robots and kind of making it actually work in production right now.
These are vendors, robot vendors, that where factories buy from these companies.
Yeah, exactly. I haven't heard from. I mean, it may happen, but I haven't heard like the factories themselves doing it and doing that yet.
I see.
Yeah.
And then like, what about on the consumer side? Like I've, had a couple rich friends that have bought like humanoid robots, and they sort of seem to kind of collect dust in the corner right now. And I've been to, kind of a robot fighting league. Yeah.
We were there too.
Which we're not sponsoring, but, I'd say the fighting seemed a little maybe unimpressive, compared to the hype around the fighting. What's the state of the art there? Like if a robot can actually fold laundry, and then the state of the art is actually like past that, why isn't there a consumer product that folds laundry?
So I think you can think of, if you just think of what it would take to fold laundry in your own home, there are more things to it than like setting it up, putting the, if you had a very expensive robot, but it required you to set everything up perfectly, maybe some people would buy that, but most people wouldn't, because of just the total setup and the kind of management of it. So just there's like the physical world has such a huge sort of long tail or fat tail or whatever you want to call it, of just weird small variations that make things a lot harder. So at the end of the day, it's not just a robot that can do a task, you need to build a product, right? So I think that distance and the whole systems aspect of like deploying robots is very difficult, right? You need to service robots, you need to have, onboarding tutorials and all these kind of things. So I think that's not where we're at yet. That like all these like most advanced frontier robotics, like intelligent robots, are at the sort of full product level yet. But we're seeing some people starting to ship robots for the home soon, I guess. Or it's exciting, but I don't think we'll see full autonomy in the home for a bit.
What do you think will be the first applications that people use in their house?
Probably picking up. I mean, the first one, the ones that are used right now, is like vacuum cleaning, right?
Well, I feel like vacuum cleaning has been around for a long time.
Yeah, there's some newer vendors that significantly make that like a lot better. Right?
Interesting.
So,
what are you thinking of?
Well, I like Matic a lot.
I have a Matic in my house, actually.
So that's like big step up from a Roomba, for instance, right?
Actually, it's funny. My daughter was asking me what's better about a Matic than a Roomba. And I think we like the sort of like mapping that it does. Yeah. But honestly, that's not really like an autonomy feature. What is better about a Matic than a Roomba?
So the autonomy, the mapping gives you autonomy, right? So that allows you to handle more robust things. Like something is in the way, it doesn't get stuck, it can not drive over your cat. And the collection of these things make it more robust and make it more useful. It's just, you get into this world or sort of this realm in the physical world where there's just so many small things that can go wrong, and they add up. And if the probability of one of them happening is high enough, you end up not using the product, basically.
Sure.
So I think there's a lot of that. The same nines of reliability kind of.
But it seems kind of funny. I mean, I feel like I remember when Roomba launched, it must have been like 2004 or something like that. And here we are 20 years later, and it seems like robot vacuums are still by far the main consumer use case.
Yeah, and I think that this is the simplest, right? So it makes sense for that. I would guess robot vacuums that also pick up toys. That's probably the next step. I know some folks are working on that. So in terms of like really practical things that can work autonomously, I would guess it's just like small steps like that will happen first.
What about fun things? I feel like suddenly we see robot dogs everywhere.
Yeah.
Like what else are you seeing in that domain?
I haven't interacted that closely with the companies that are building more toys, but I mean, I'm super excited about that. I think there's so much fun things like that can exist. There are like AI powered robot toys and so on, but that's not a space I know really well.
I guess what else are you seeing in terms of applications?
I think very broadly, we're seeing things in like agricultural picking.
Mhm.
Just something that I didn't really realize was just the breadth of how many places there's this like last mile kind of logistical pick and place thing. So there really is a lot in different parts of the logistics chain, um, as well as like there are many times of like small autonomy, um, last mile delivery, these kinds of things. I put them in the same, and it's sort of close to self driving, but sort of see it as the same realm as robotics as well.
Mhm.
Drones. There's just a lot of different applications there. Um,
Yeah, are you saying, I mean, am I maybe overly focusing on robotics? Like, do you
mhm,
see other like embody AI or other applications like outside of robotics that are meaningful to you? Like, how does your customer
mhm.
base break down?
So yeah, I think our sort of customer and user base breaks down according to just if you're trying to do something intelligent for the physical world
Mhm.
mostly, and that will split into the big categories being AR, spatial computing kind of things, autonomy more
Mhm.
broadly, and robotics.
Mhm.
But then there's just like a long tail of smaller things, and
Totally.
like I mean, just it can be really small things like a media thing, the little AI thing in like film production that makes like focusing easier. Just like there are huge amount of these like small little problems. It's quite a lot in like security, surveillance, like analytics for construction, that kind of stuff. They're just basically any physical world thing that's happening out in the world.
Mhm.
Someone's probably building a product to either observe and analyze it or actually improve it. Yeah.
Are you seeing like a lot of satellite data applications?
We don't see a lot of that internally because they're just product features. We haven't built a lot of like specialized satellite data handling. We
Mm.
have basic mapping, but that's a whole very deep field.
Uh-huh.
So we don't see them necessarily as huge rerun users yet.
Mhm.
But I sort of aside from that see some cool stuff happening.
Cool. Um, all right, I kind of want to go like a little bit deeper into your product, if you
Sure.
don't mind.
Yeah.
I think like one of the things that we really, designed our product for is making sure that doesn't like break the user's
Hmm.
process. Was that like a big thing for you? I'm curious how you like to actually stream the information back to like a central server.
Yeah. Yeah. That was important for us too. So I mean, just things like you can never crash the user's process and
Yeah.
things like that, of course. Um, so we originally designed it heavily in cases where, um, let's say, like we focused a really lot on high performance streaming.
Mhm.
So there's all the robustness aspect. I don't know that I have anything particularly like interesting to say other than that we spent a lot of time making sure it could never crash.
Mhm.
But in robotics, um, we didn't design it for the case of hey, there's always a server listening.
Mhm.
So quite often in robotics, you can't guarantee that, and the kind of normal thing to do is write to disk first.
Mhm.
So the two kind of core original use cases, like either writing to disk or streaming to a remote
Mhm.
viewer or something like that, a remote server. So yeah, we designed for both of those, and our sort of on disk format is basically the same as the streaming format.
Mhm.
And so to make these things fast, we built this you log data, and depending on the size, you can control these things, but we basically run a micro batcher
Mhm.
such that you buffer up a little bit of signals in memory. And if you're having really, really fast time series, maybe you buffer up more
Mhm.
and then sort of send it over the wire in sort of chunks
Mhm.
like that instead. And that balancing that and kind of doing that efficiently is like one of the important parts of getting reasonably
Mhm.
good performance out of these things.
I mean, one of the decisions we made that I'm never sure if it was the right decision or
Yeah.
not is we had the logging be open source because it's like running in
Hmm.
the customer's or the user's environment.
Yeah.
But then we made our visualization, the centralized visualization web server,
Uh-huh.
closed source.
Yeah.
I think you made that whole thing end to end open source.
Yeah.
Is that right?
Yeah, exactly.
And then how did so is that why you had to make like a different product to monetize, or did you have like a more enterprise version of the visualization server? How did you think about that?
So we had this idea that visualization would be hard to monetize. actually because of how important it is. So we had the idea that particularly for this like physical AI kind of applications, you need to visualize every single step of the, like everywhere you might interact with data. You need to visualize when you're like prototyping in a notebook. You need to visualize when you're like, you have like maybe one robot or one device like next to your desk and you're like kicking it to figure out like what's happening live. You want to visualize your like data pipelines as you're like preparing for training, eval, just like everywhere. And you want to use it for your operation. It's just too widely deployed. And that there's no good business model that lets you have visualization in all those different points that works. If you can make the business model around a per seat license or something like that works for your like expensive engineer that's looking at the data all the time. But you also want to have the same visualization for your like support person who looks at every now and then, or like just that balance becomes very difficult. And having it closed source, if it's so central, it actually becomes very difficult to adopt for a lot of companies. So we basically decided to have the base visualization be open source, and kind of always has to be, just so it's like easy to embed. And and you need to be able to build your own tools around the visualization that are custom to your company. So you should be able to take the visualizer and embed it in your application and customize it. So the open source visualizer is sort of client side. So that's kind of how we made that split. That like there's a logging SDK that runs in your process, and it directly communicates, like maybe via the file system, but like directly communicates with a visualizer app. And there's no real serious server in the middle. So that's kind of how we started that out. And I wouldn't say the commercial product is a different product, but it's a cloud sort of backend for it instead that supports like very large amounts of data.
I see. So we might have actually ended up in the same place, although you might have more emphasis on the client-side visualization, which we've actually just implemented recently.
Yeah, it's kind of, I think, similar in that manner, but just took a different route, perhaps.
Interesting.
Yeah.
I guess, have there been interesting API design trade-offs that you made? And is there any like API decisions that you sort of like regret? Like I remember we made a ton of decisions in the early days, very quickly with like no information, and it's amazing how some of the weirder ones that we made have like stuck
Still
and haunted
around.
us for years.
I think there are more detailed things that I don't know they're worth like getting into, whatever specifically how we designed the tensor data model, things like that. But I would say rather we designed things wrong and then redesigned them. So we've actually redesigned the data model probably 4 times at this point.
Oh, wow.
So that has been like very effortful, right? And it's been hard. We had to keep some backward compatibility and kind of do all these things. Been quite difficult, but yeah, we kind of really cared about getting those core pieces right and been ready to redo it.
I mean, this may be too in the weeds and people might just skip this episode, but like what are decisions that you made in the data model that you then changed in like the next version of the data model?
Well, the first one was this, we started out with a less flexible API. So we started out like in the beginning, it was like, okay, this is getting very detailed, right? But it was like rr.log_image, and then you'd like give it all the fields. And there was still a flexible way you could give your own custom data into that. So that was the first huge rewrite where we kind of formalized the sort of system to have a higher level of like archetypes, which are sort of easier to use wrapper objects that you can log instead. So now it's like rr_log, then parentheses image, say, right? And yeah, so that was a huge one. And then a lot of the other data model things that we've been changing are maybe more not as clear on the surface, but it tends to do with how you represent columns of data. It's like more like being able to log more data for multiple timestamp at the same time. For instance, like here's a whole column of data, or here are like 5 columns of data, and sort of those APIs and exposing that. And then so that's been one set. But the most maybe difficult to do and impactful things have been maybe more how it's represented in memory and how the data model works sort of in the query engine of the database. So those rewrites have been they're very impactful for performance and things like that and storage, and pretty painful like to redo. I think we've redone that 3 times or something.
Yeah,
Um,
totally. That's funny. A lot of similarities
yeah.
between our companies. What database are you using now to store all the data?
Yeah. So on it's custom basically everything. So everything open source is built in Rust from the ground up, and we use Arrow. So
Yeah, yeah, we do
yeah.
too. Yeah.
So that's basically built around Arrow, and everything is custom. So it kind of comes down to the special properties of what we call like physical data.
Hmm.
And so physical data will be like multimodal, multi-rate, and often like episodic.
Hmm.
And that just changes how you need to store that data. It doesn't like you can't fit that kind of data in like a table. Because it's multi-rate. That means maybe you have motion happening very fast, and you have like images coming very slowly. So they just data on a robot is happening at different rates. It just doesn't work if you can't fit it in like a normal tabular model. So you just have to store data differently. So yeah, it's a new file format for doing that efficiently. You could think of it as like a sparse version of Parquet or something like that we use. A new indexing system. So we like kind of built all those things from scratch.
I was curious about your customers,
Mhm.
across all of your customers, are there kind of like consistent blind spots or things that they consistently discover when they start to use Rerun to be able to visualize all of their logs?
So let's say you can split on like customers and users to start with. As the users of the open source, um, I think the really big qualitative thing there. So what the open source really is mostly giving them is like visualization but it being like radically simpler for them to do. So they do a lot more of it, and like there's higher performance and so on. So everybody is already doing some amount of visualization. So it tends to be maybe about volume. Like you look at like a lot more things. You're debugging the intermediate steps of your data pipeline and so on. And so it just is a higher volume and therefore higher hit rate. So we'll have people tell us like that are working on some big self-driving car project, and they found bugs in their training data pipeline that have been around for 3 years. So those kinds of things. So that would be on the open source side. I think on the commercial side, the biggest like aha things tend to be that they can build like just significantly simpler data pipelines because we have a different storage layer than is used in kind of normal data. And so just the fact that you can build, how simple the kind of data pipeline structure can get is kind of tends to be one of the really, really big sort of aha or like unlocks that they can do that very differently.
So one place that guests on the show have really differed in
Yeah.
perspective in kind of physical applications is how they felt about simulations. Like it almost felt like almost like a religious feeling in some of the interviews I've done. I'm curious where you land on sort of like training and simulation, and then like what fraction of your customers are training and simulation.
I think I'm more on the agnostic side personally.
Sure.
Just coming from that, I'm not personally building these things, so I try to just kind of keep an open mind.
Totally.
So we see both. I would say the users of our commercial platform do not only rely on simulation. Like if you're like really just relying on simulation, then you have a little bit lower need to care as much about how you're like saving your data basically. So if you don't care about saving your data at all, then you don't need a sort of database to store it. So because of that, we get a sort of bias towards people who care about real data. And I see that's also what I see mostly in the companies that are building products that interact with the real world. I don't think anyone knows yet that it's possible to do that well with just simulation. You most likely need a lot of real world data to do that.
Totally. So you're a practical guy like me, building for practical people, practical product. But I was curious, have you ever built a feature in your product because it kind of gave you a spark of joy, even if there's no real like obvious case for it?
Like it would give me personal joy, you mean, that it's there? I don't know that there's no case for it. We have, but I've like, forgotten about it. But I think there are some aspects where we've really, really prioritized like small mini interaction performance. It's like we really care about like how fast it is to like scroll back and forth in time. So the rerun viewer is like it feels a little bit like a video editor or something like that. You can scroll back and forth, and just having incredibly low latency on that. Like that probably doesn't matter as much as we care about it, but
maybe it does.
but it just feels really nice.
Yeah.
It just has this like, it feels amazing.
Totally.
And I think that people react with that. We get a lot of people who just, I don't know, that gives you something visceral.
Yeah.
But you can't put that on a spreadsheet for sure. Yeah.
Totally. I love that answer. Do you I guess, do you think, okay, I have a couple rapid fire questions here. Just let's see where they go. Okay.
Mm-hmm.
What do you think there's like an underrated robotics startup that you'd want to call out?
Yeah, I don't want to like pick favorites here.
I mean, this is like being positive though.
Okay. Yeah. Underrated. Let's see. I'll say one on the sort of modeling side that I think is talked about too little, at least. They're not, it's like generalist AI, and I'm very impressed by what they've done on the sort of ship.
And why? Tell me why you think they're...
I think they had a really lot of foresight on the method of how they're going to collect data, and like really went for that very seriously.
And what was the method? Can you say?
It's public. It's called UMI, but basically, I don't know if you've seen these videos where people put like, they're holding like, it's a person, but they're holding a little robot gripper kind of. So that with a camera on it and so on. So they're like more puppeteering a fake robot. And so they bet on that and have really scaled that up and are showing a really, really impressive sort of dexterous manipulation. So I was impressed by the sort of strong bet on that direction, and like really making that work. It's been really cool. On the kind of, there are two companies, the other examples I think are great that are more on like ship and deploy. I think Ultra is a really great company in the more like pick and place for logistics.
And why do you think of them?
They're just very, I think, good at shipping and learning from that, and like building real systems, but still being AI first. And just sort of seen them doing that very well. There's a European company called Syriac that's like really good at that same thing. They're in different space, more manufacturing, but I've sort of seen them do like very practical, like shipping oriented, and I think that's really cool to see.
Cool. Okay, do you think that there's new data formats that you're going to need, say, if we roll forward 3 years? Like, what do you think are like maybe new sensors coming along, or new types of objects that you're going to need to visualize in your product?
So I think force and tactile touch are clearly becoming a lot more popular. And it's natural, right? You'd expect it's difficult if you imagine like losing your sense of touch or in your hands. Picking things up is a lot more difficult. And so unexpectedly that helps for robots too. So that, I think audio, sort of more things audio as well. So those kinds of things.
Okay, so in the LLM space that I'm much more familiar with, the language space, actually where I started and where we see more of our customers these days. There's tons of benchmarks, and there's all this fighting about like, okay, like, is this a good benchmark, a bad benchmark? People are like too oriented around benchmarks, but I feel in robotics, you don't really see benchmarks as far as I can tell. Are there benchmarks that you think are meaningful? Are there benchmarks that should be created?
This is like a hot topic in the field. I don't have a super strong opinion that's better than anyone else in the
you're a guest, so yeah, that's true. Give us your opinion. Yeah,
but I'll say it's a huge problem for the field that there aren't any great benchmarks.
Maybe who can fold laundry the fastest?
Yeah, but you end up with this difficult situation where the way often to solve real problems is to co-train and co-design for your hardware. It's like you design these things together, and then it becomes quite hard to benchmark in a good way. How you're gonna logistically do that, right? So you for something to be practical, almost has to be simulation based, and then you have all the problems with simulation and not being particularly difficult for like manipulation and interaction with the physical world, and perfect simulator, and that doesn't exist. So I actually don't know what the solution is, but it's super super important. But I imagine we'll see much more of companies driving that for themselves. the sort of internal benchmarks, and then like companies will have these like farms of robots that they evaluate, like, hey, we have a new model, deploy it, and they run tests live on real things as the way of testing things. And I would imagine that will continue to be that way for a bit.
Okay, so a few years ago when I was messing around with robots in my garage, it seemed like everyone is using this thing called ROS, and it seems like everyone kind of hated ROS, but like still used it.
Yeah.
And I was kind of surprised to see on your website, it seems like ROS just has incredible staying power. Like you still integrate with it.
Yeah.
What's your do you have like a take on it, whether it's like good or bad? And what is why hasn't it been replaced if so many people are griping?
Yeah. I think it's one of these things where it's almost a part of every roboticist journey to have a stint of like, I'm going to rebuild ROS, but right this time. I think like very many roboticists have done that at some point and then given up. I think the really core thing is that they're ROS is a proof that network effects work. That there's just a build an ecosystem around it and kind of evolving standard, and it's just very hard to kind of come out of that. And then the other part is that it's solving a problem that is difficult to make general. So like at the heart of ROS is it's kind of a message passing system. So there's a way of a common set of message definitions, and her message could be how to represent an image that you can pass around, or a 3D pose, basically where something is. So just any data that you might have. And it turns out very useful to have a standard set of those. And most companies will have their own versions, but if you have a set of standards, then you can build pluggable systems. Like someone builds a pluggable open source like navigation module. So, and those things all add up, and that's just really, really hard to get out of. We actually see a bunch of quite a little bit more serious efforts now to replace ROS. Let's see how it goes. I guess it's definitely a difficult problem, but I think in particular it's hard to fund.
Right.
So that I think ROS would be better now if it had been better funded, but it's just hard to find a good funding model.
Well, it's astonishing because so many well-funded companies are using it.
Yeah.
You'd think there would be more of maybe an open source collaboration like you see with databases or something else.
Yeah, I don't know that we see that databases really have that at super scale until they're... Yeah, maybe there are a couple databases like that, but usually there is a team first that like really takes it really, really far. And then that kind of continues. But I don't know why that hasn't happened with ROS, but it certainly hasn't.
Well, good segue into one of my final questions, which is, when you look at some of our joint, customers that are doing these general purpose, robotics applications that, are raising at like astonishing valuations pre-revenue. Like we've never seen these kind of valuations pre-revenue before. Does it feel like a bubble to you or not?
It's hard to know. There's some of that, but I think, they are going after astonishingly large markets. And I think there is something particular about general robotics, which is like there is I see the point. Is one of the hardest parts of robotics is making a decent price point for the hardware, and you kind of need a really lot of scale for that. And the best way to generate scale is to be able to serve a lot of use cases with the same hardware. And so that also requires a lot of scale, because then you need a very large amount of data, basically, and compute to make that happen. So I kind of see why a lot of capital gets amassed to go after it.
Are you a fan of the humanoid form factor or not?
I mean, I'm a fan because I'm just sort of an optimistic person, I think. So I would love to have a humanoid that was like doing my dishes and
do you think it will be a humanoid?
I think long run for home tasks, I think there are a set of tasks that are likely to be humanoid or humanoid-like. I think in the shorter term, in many cases, I think sort of a semi-humanoid is a much more practical form factor, like a wheeled fixed base with arms and that are humanoid-like.
It's like Jetsons.
Yeah, a little bit that kind of thing. I think the thing that human-ish form factors have going for them is data collection.
Mhm.
So just like you could imagine, maybe it's more efficient to have 4 arms, but it's really hard to have a human control 4 arms at the same time.
Mhm.
So as long as the real world like data collection is important, I think that's just like that's a really important factor will be hard to get away from.
Is there a tool out there in your space that you wish existed but doesn't?
That's a good question. I don't know. I don't know that I've.
You'd
It's
probably
like,
make it if there
yeah, I'd
was, right?
probably make it in that case. Yeah.
All right, and last question, I guess, what do you think is the biggest breakthrough likely to see in the next year or two in your space?
Um, honestly, I don't know. I think significantly improved robustness, and that really is one of the main thing that matters. I think over the next year, seeing more and more like larger, longer, and more complicated tasks be able to be performed like in a robust way, like self-correcting and so on, and a little bit more like learning on the fly. I think that's a likely trajectory if things go great this year, and my guess is going to take a little longer for this more high level, combining that with like really great high level reasoning as well. So that maybe that's the year after. But no, I'm not just guessing. Yeah.
I guess in your experience, how is training embodied AI or robotic systems different than training LLMs?
Yeah. So maybe I can start with some things that are common. So
Mhm.
I think the things that we see the absolute best sort of AI team, LLM teams, and physical AI teams do is kind of have the researcher, the modeler work on sort of both the data and the modeling together. Like the same person is kind of making complicated decisions about exactly how to pre-process data, what data to include, and the modeling.
Mhm.
Um, and so that's like super core.
Mhm.
And it just turns out that that's a lot easier to do for like LLM teams.
Why is that?
Also, yeah, there are maybe like 3 core things that you need to be doing. So you need to be looking at your data just like all the time.
Mhm.
And for text, you can, just read text. Like it just kind of comes in. And if you have
Um,
other signals, you just like they're very easy to visualize. But doing that for physical data is very difficult.
Mm.
That's a little bit more closer to solve, like for tools like Rerun.
Mhm.
The other part becomes this, like you want to have very flexible, like make it possible for the researcher to kind of be editing the data pipelines and so on.
Mhm.
And on the and you will need to have like high performance when you do that. So you want to have both of those things, high performance and flexibility. And for LLM data, that's like text and normal things that you can use like sort of robust, well-proven storage formats like Parquet, Iceberg, and things like that, and like high-scale data processing engines like Spark and sort of Databricks. Those kinds of tools have been around and matured quite a lot that allow you give you these like easy declarative database style APIs to edit how the data comes in. But for robotics, like none of that exists basically. So all the data formats are built for a world before machine learning.
Mhm.
So they're not flexible. They're really optimized for like fast logging rather than like flexible querying.
Mhm. And when you say flexible querying, can you give me an example? Like
Sure.
I'm imagining like I want all the, places where it was recorded at night or something like
Yeah,
that.
exactly. Let's say I want all the times that it was like at night and the left gripper didn't open and there was a failure of type whatever, right? Type B. And so that might require you to query the metadata
Mhm.
and the signals sort of inside a specific recording.
In fact, are you doing some kind of like semantic embedding to make that possible?
Some users do that,
Uh-huh.
but you could just be normal querying, like this signal value is above 5, or
Right,
and this other thing is this, and the text is whatever, like the
Mhm.
text description. And so the kind of normal robotics stack
Mhm.
doesn't have a query or sort of a format where you can represent this sort of multi-rate physical data with sort of 3D or whatever, all these different things that you can store it in a file format and have some kind of just database query engine that can operate on top of it. So you end up having to put in these file formats that are optimized for saving logs,
Mhm.
and then there is no query format. So the way you answer all these questions is you write a huge parallel job that reads the file into memory,
Mhm.
like reads field by field everything, and you're like writing imperative custom code for every such query and running it on a huge parallel job and aggregating it manually. So it's just like a huge amount of work where it should just be like a SQL query or something like that.
I feel like I'm seeing, kind of a converging in some cases of,
Yeah.
LLM models and embodied AI models. Like for example, one of our customers, Wave, actually uses an LLM to describe what the car is doing as
Yeah.
it's driving around, which
Yeah.
is really kind of interesting. Do you see other things like that happening?
Yeah, I mean, particularly for data annotation,
Mhm.
that's a really, really big one. So you'll see a lot of teams doing like they'll train one model or use an open model to just annotate their robotics recordings to just say, oh, here's where it started or stops. This is the task that it's doing right now. Things like that. And obviously using computing embeddings for images and motion and stuff like that for search and curation. So
Mhm.
both of those are super common as well.
One thing that I think about, for weights and biases is like,
Yeah.
we see more and more like agents like interacting with our product.
Mhm.
And we've been pretty passionate about like doing really good visualizations.
Yeah.
But I kind of wonder, like, I think a lot of people now, they just pull the data out of weights and biases and then, use Streamlit or Marimo or something to just like,
Yeah.
conjure like their own custom visualizations.
Yeah.
And I've been thinking like, ooh, like, do visualizations even really matter in like 2027? Do you have a perspective on that?
I think it will continue to matter, but potentially it will not be good. Like people will do more and more custom visualization based on this. So we actually see that happening quite a bit. Like you use Codex or Claude or whatever to just
Totally.
I need this special case little visualization, and then just kick off an agent and it'll build your specialized tool. So if like SaaS style applications where like building a very dedicated tool like that, I would imagine that gets harder and harder. And the underlying systems, is assuming they need to be very like high scale and robust. I think that
Right.
I would imagine that to have some more time on it at least. Yeah.
Okay, this is another just
Mhm.
I feel like I'm like just fighting my own demons here, but is there any trade-offs that you have between, kind of flexibility for people in the first case where they're just kind of setting things up and just like kind of messing around
Yeah.
versus like real scalability at like production volumes?
So I don't know that it would be exact about scalability for production volumes and flexibility. To be honest, I think we kind of solved that. That took like 2 years to like on iterating on this data model thing, and I think we got a really good design that can kind of fit both. Of course, we don't get all the way. Like for instance, so the way our system is designed, we'll never get to our logging being useful for like really low latency teleoperation. It's just not built for that.
Yep.
So we won't get all the way there. But I think maybe more importantly on like usability. So we want to have a thing that's flexible enough for researchers to use. And one of the things that go into that is we don't want to require you to like compile a schema before having to log something. Right? But in production use cases, having systems that are a bit more built around like a pre-compiled known schema, these are exactly all the things that are going to come. I guess that gives a little performance, although you can work around most of those performance problems. But that can be actually lead to a bit more that can fit a bit more naturally into those systems. So that like ease of low friction for a researcher usability versus, hey, I'm plugging this into my already existing schemas and sort of production system. That then has taken us a lot more work to kind of work for there too, and we still have a little left to go on that journey to like really cleanly integrate with those sort of production systems, so that like robot production systems like that. Yeah, that's been a big trade-off for us for sure.
What about do you get a lot of open source contributions?
We do, but it's not. We should get like a medium amount. I would call it like.
Do you think it's like worth the overhead of managing it?
I think it is for us. It's not. If it was just for the sake of the contributions, it would not be worth it. There's we need to review pull requests and so on, and so for that purpose, no, not really. So for us, open source is it gives a lot of trust, right? So it's like very easy to adopt. And I think there's those just, it makes it very easy. So Rerun gets built into a lot of other open source tools. Right? So one of the most impactful open source projects in robotics learning has been Hugging Face's little robot project. And they built Rerun into that for the visualization, and that wouldn't have happened. And then we built into like NVIDIA's a new simulator engine, and gets built into that. And so those kinds of things matter a lot. In terms of contributions, I think it's actually more in terms of some company wanted, or some person or someone really loves Rerun, and they have some little thing that they are really annoyed about, and having a way for them to do that. And maybe it would have practically been easier if they just asked for it and we did it, but that kind of participation builds a kind of relationship with people that I think that adds up more than the particular thing. Yeah.
Awesome. All right. Well, thanks again.
Yeah. Thanks.
Yeah. Thanks so much for listening to this episode of Gradient Descent. Please stay tuned for future episodes.